An integral part of evaluating outcomes in data collection is understanding the role of measurement. In this presentation, we will look in depth at the theory and process of measurement. This will help you both in planning EBP and QI projects as well as in reading the literature. Measurement is about the rules for assigning numbers to represent the quantities and qualities of objects. It is the assignment of numbers to represent the amount of an attribute present in an object or person using specific rules. Its advantages are that it removes guesswork, provides precise information, and is less vague than words. Its disadvantage is that it reduces phenomena to numbers, and so some of the richness of the data is lost. There are 4 levels of measurement for data. The level of measurement determines how we can use the data statistically and in all mathematical analyses. Nominal level data means that the numbers are assigned simply to classify characteristics into categories. One is not better, worse, higher, lower, more or less than the other. They are just separate. Eye color would be a nominal measure. Blue, brown, and green are simply different from each other. In ordinal measures, the categories now indicate rank or relative standing on an attribute, but not how different they are. Finished place in a race is an ordinal ranking, as the distance between the points is not the same. The second place person may be 1 second behind the first, but the third place may be 3 minutes behind the second. In interval level measures, objects ordered on a scale that has equal distances between points on the scale, but there is no meaningful zero. Temperature is an interval measure. In ratio level measures, there are equal distances between score units, and there is a rational, meaningful zero. Height, weight, and age are all examples of interval level measures. A variable's level of measurement determines what mathematical operations can be performed in a statistical analysis. Rarely is any score completely accurate. Every score will be slightly off from perfect. Error of measurement is the difference between the true and the obtained score. The obtained score is an actual data value for a participant. For example, an anxiety scale score or a blood pressure measurement. The true score is the score that would be obtained with an infallible measure. Error is any factor that distorts the measure, causing the obtained score to deviate from true. So the obtained score is the true score plus or minus any error in the measuring. Many factors may contribute to errors of measurement. Situational contaminants are the conditions under which a score is obtained. With a room that is too hot, too cold, or has poor lighting, scores may be affected. Transitory personal factors such as fatigue, hunger, or mood changes may also affect scores. Administration variations can cause error. If all of the data collectors do not administer the measure the same way, error will result. In written surveys where only a subset of items is given to each subject, error can result from item sampling or changes in items that are used. A psychometric assessment is an evaluation of the quality of a measuring instrument. The key criteria in a psychometric assessment are reliability and validity in relation to the instrument. Reliability is the consistency and accuracy with which an instrument measures the target attribute. A reliable instrument will be accurate, meaning it measures the true score with a minimum amount of error. There are generally 3 aspects of reliability that are examined: stability, internal consistency, and equivalence. Stability is the extent to which scores are similar on 2 separate administrations of an instrument. It is commonly evaluated by test-retest reliability. It requires participants to complete the same instrument on 2 occasions or to have the measure done twice. It's appropriate for relatively enduring attributes such as height or IQ. For more transient attributes such as blood pressure or potassium level, the measures need to be taken in close time proximity to each other for the measure to be meaningful. Internal consistency is the extent to which all the items on a written instrument are measuring the same unitary attribute. It's evaluated by administering the instrument on one occasion and then comparing items to see how well they correlate with each other. It's appropriate for most multi-item instruments and is the most widely used approach to assessing reliability. It is assessed by computing a statistic called coefficient alpha or Cronenbach's alpha. Reliability coefficients can range from 0 to 1, with coefficients below 7.7 considered unsatisfactory and coefficients of 0.8 or higher being desirable. Equivalence is the degree of similarity between alternative forms of an instrument or between multiple raters observers using an instrument. It's the most relevant for structured observations and is assessed by comparing agreement between observations or ratings of two or more observers. This is generally referred to as inter-observer or inter-rater reliability and is expressed as a percentage of times the two raters agree. Validity is the degree to which an instrument measures what it's supposed to measure. For example, if an instrument is supposed to measure assertiveness, how do you know it's measuring assertiveness and not aggressiveness, self-confidence, or some other similar attribute? An instrument must be reliable to be valid. If it's not measuring reliably, no faith can be put in what it says. However, just because an instrument is reliable and that it measures consistently does not mean that it is valid and that it is actually measuring what it claims to. For example, I could get a micrometer and very precisely measure the length of subjects' noses. I could do this multiple times and have a very reliable, accurate, repeatable measure of the length of the noses. However, if I then said that nose length indicates intelligence with longer noses meaning higher intelligence, I would lack validity. So I would have a reliable measure of nose length, but an invalid measure of intelligence. When looking at validity, there are generally four aspects of validity that are measured: face validity, content validity, criterion-related validity, and construct validity. For any instrument, usually not all of these are measured. Face validity refers to whether the instrument looks as though it is an appropriate measure of the construct, hence face validity. It is based on judgment and opinion with no objective criteria for assessment. Because it is based on opinion, like opinion in any hierarchy, it is the weakest form of validity. Content validity is the degree to which an instrument has an adequate sample of items for the construct being measured and adequately reflects the construct domain under study. It is generally evaluated by assessment of objective criteria, often via a quantitative measure, the Content Validity Index or CVI, that can result in a numeric score. Criterion-related validity is the degree to which the instrument is related to an external criterion. The validity coefficient is calculated by analyzing the relationship between scores on the instrument and a criterion or gold standard. There are two types: predictive validity, which is the instrument's ability to distinguish people whose performance differs on a future criterion, and concurrent validity, which is the instrument's ability to distinguish individuals who differ on a present or concurrent criterion. Finally, construct validity is concerned with the question of what an instrument is really measuring and does it adequately measure the construct of interest. It is assessed by the known groups technique, which tests relationships based on comparing them to a group who are known to be high or low in the attribute, or by factor analysis, which is using statistical means to reduce and categorize the data on attributes or constructs. Sometimes one needs to assess and screen diagnostic instruments. This is generally done by assessing the sensitivity and specificity of the instrument. Sensitivity is the instrument's ability to correctly identify a case or diagnose a condition. It's the ability to determine who will have the trait of interest. Specificity is the instrument's ability to correctly identify non-cases, that is, to screen out those without the condition or to identify those who will not have the trait of interest. So to summarize, Measurement is about the rules for assigning numbers to represent the qualities of objects. It is the assignment of numbers to represent the amount of an attribute present in an object or person using specific rules. The key criteria in assessment are reliability and validity. Reliability is the consistency and accuracy with which something measures the target variable. Validity is the degree to which an instrument measures what it's supposed to be measuring. Many factors may contribute to errors of measurement. The goal of sound measurement practices is to minimize the error present in any given score. This has been a brief introduction to the role of measurement. If you have any additional questions, please don't hesitate to contact your instructor.